All right, so Anson, here's my thought. Here, if we have an auger and we take these big long poles and we attach them to the auger, and you and I push them around, or Aaron and I push them around, and we just put 150 foot-pounds force, which is not that much, on those 90-inch long augers. What that'll do, I think I might have this actually reversed. I think I need to, yeah, we'd be pushing the other way actually. Um, so push, yeah. 150 foot-pounds force would be equivalent, on both sides, a total of 300 foot-pounds force. So the 90 inches, it's like if you and I push on each side. And 300 foot-pounds force, I was looking to what does that convert to, or how's that equivalent to the 1,600 to 5,000 psi that the industrial companies, set their gauges to get the kind of compression they want for like big buildings, holding up foundations, shit like that. So anyways, we push this around, we turn the auger, we would have to bolt the auger in the middle, but anyways, so let me look at some torque settings. That's no good. Let's see. So here's a graph that shows, so here's a graph that shows, PSI conversion to foot-pounds force. As you can see, 1,600, which is just like 600 and some odd foot-pounds force, compare and up to 5,000, which is like PSI, which is 2,000, a little over 2,000 foot-pounds force, would be required to get like industrial equivalent, torque on that auger. And so if we, what does it take for us to put, 2,000, a little over 2,000 foot-pounds force on that auger? Well, if you look at even anywhere from, this low 600 some odd to 2,000 some odd foot-pounds force, that would be considered like an industrial equivalent from everything that I've seen from companies that are doing this. So if you just do the calculation, what it comes out to is basically right around 300 pounds of force. So, you pushing on one side 150, me pushing on the other side 150 would give us like the maximum amount of pressure that I've seen anybody use on these systems. So that would give us, like equivalent of 5,000 psi on the hydraulic gauge on the skid. So that'd be like totally industrial. Now we'd have to bolt the these pipes to the auger, which I've already done, and we have to kind of create like an auger attachment. And so I can just cut a piece off of one of the existing extensions and use it and attach it, detach it, and put these bolts in place. But we also have to be able to shrink and extend these pipes, because sometimes there'll be a bulkhead, like you're turning around and you'll hit a bulkhead or something is in the way, and one of us is going to have to shrink the size of these pipes. You don't want to have to keep bolting and unbolting your connections. So I'm thinking we could just create some telescoping pipes by inserting smaller pipes into larger pipes. I think it's doable. I have some ideas. But anyways, so that's the plan. Figure out how to create telescoping pipes so we can move in and out. Just plan on putting 150 pounds of foot-pounds force on each side and just go round and round. And that'll just drill that auger down into it's attached, bolt, put a couple bolts through it. It'll drill that auger down into the earth at the industrial compression strength required. So that's it. That's what we'll talk about tomorrow. Thanks. See ya.